Good morning, everyone, and welcome to the Voltha TST meeting for May 10th, 2022. As a first, I reminder that there will be a Voltha meetup in Berlin the 19th and 20th of May. So if you have the opportunity to join, I'm pretty sure that it will be plenty of interesting content there. Unluckily, I won't be able to personally make it to Berlin, but I know Andrea will be there for sure, and a bunch of other people in the community will be joining the meetup. So again, if you can join, it's going to be a very interesting meetup. The second thing we had on the agenda to discuss for today was the continued investigation on LWC. We were seeing different results than Radisys was seeing on our setup. So we did some more testing in the past week, and running on kind, we see absolutely no difference. We tried to run the test with 256 ONUs, both on a virtual cluster using kind, so Kubernetes in Docker, and on a physical 3-node clusters. And the results we're seeing are definitely aligning with what Radisys is seeing. To share the numbers, when we run on a single node kind cluster with, as I said, 256 ONUs, the entire test completes in 25 seconds, which is incredibly fast compared to ONUs that, if I remember correctly, was in the 200-something second range. When we run the same test on 3 nodes, still on a virtual cluster, so it's actually 3 different Docker containers running on the same physical machine, we still see no difference. But as you can see, from a deployment perspective, the 2 different pods of Redis and LWC, I think that they are on different nodes, and we still see the test completing in 25 seconds. We tried to replicate the same test on a physical cluster, where this time LWC and Redis are deployed on 2 different containers, on 2 different machines in the same network. These 2 machines are co-located in the same data center. And we still see the result being pretty good. In particular, we were seeing this step being very slow on our test cluster with 500 ONUs. We don't have that cluster running anymore, but we see this step going very, very fast now. So at this point, the only thing I can do is assuming that there was some wrong configuration with that cluster. And we'll just have to verify this once the cluster will be back online.
That's good news here.
Yeah, I agree.
This is with persistency enabled, or?
No, this was, I believe it is without persistency enabled, because I think the charts you gave us don't have persistency enabled by default.
Okay.
I can just check, but if I look in Voltha infra charts, yeah, I don't think it's enabled, because we're not. Oh,
enabled. Yeah, because if you've taken the one which we are given, because we run it persistency enabled, so that's why I just wanted to cross check.
Yeah, then it is with persistency enabled.
Okay.
So when we look for persistency here, do you know which kind of persistency we're using? Because I think this is persisted in memory.
Okay, it's not mounted, is it?
I don't think it's mounted by default.
Yes, I think so, yes.
Or actually it might I think this might be mounting it on the same node where the where Redis is running.
Yeah, possible, yeah.
Yeah, so this might be the difference we were seeing with the scale cluster, because in that cluster we had deployed support for distributed persistency. We were using a backend which is called Longhorn, that basically mounted a shared file system into the container, and this file system is shared across all the nodes in the cluster, so that even if a node goes down and the pod is restarted on a different node in the cluster, it will still have the data in memory. But that for sure introduce a little delay in reading and writing from the file system.
Yes, yes, could be that. That could be the reason as well. Yeah.
Yeah. So this is definitely something we I want to take a look at. I'm gonna add. Okay, sorry for the typing, but so I can add a to do for myself. And this is a very good point, because this is the only difference we were seeing, and it will be good to get down to the bottom of it. That said, I personally believe that LWC is way more, is way faster than ONOS, and it's also a lot more lightweight, as it doesn't carry all the complexity that a full SDN controller needed to carry. So I think this will be a very good improvement going forward. Does anyone have any question or comment on the topic?
Hi all, this is Andrea. Sorry for being late. So we had a discussion in the operator TST call, and there was an agreement that we will be accepting Radis's code as part of an open source contribution to a repository to put in place an option for the controller. This is very clearly not the decision on the replacement for ONOS, but it is a way for the community to look to Radis's code on LWC and evaluate it in the light of the design that people want for an ONOS replacement. And it is possible, as Netsia and Telecom suggested, that there might be other open source options in the upcoming future. And those will be, as I said, options aside with LWC that will be open sourced as well. And then the community will again evaluate those options as well and make a final decision on the controller. So what the next step is for us to create a repository where we could host the Radisys proposal for the controller, and where people could take a look at this implementation. And based on that, there will be evaluations done on the design and on the code itself. And then the community, the operators, the area governing board will decide what will be done in terms of the replacement for ONOS. I want to be, again, very clear with everybody. This is not the decision of using LWC as a replacement for ONOS. It's merely a decision to help the community see the code and evaluate it as best as possible for finding the suitable replacement for ONOS. Let me stop there and see if anybody has any questions. Okay, no, and if not, Theo, can you put an action item on myself to create that repo?
Yeah, I can do that as well, because it's the end of the day for you. So
Do you have the permissions?
yeah,
Because I don't. I always go through Zach.
yeah, I
Okay.
do have permission. So let me just do it.
Yeah. Call it something like Voltha. Call it lightweight controller Golang or something like that.
Yeah, we can take this offline.
Yep, sure.
Uh,
Any suggestions for the name of the repo? No, okay, fine.
Anyway, I think this is a very good news. I'm glad that DTST accepted this contribution from Radisys, and I think it's going to be very good for the project in the future to have the option of using different controller to manage the stack. And I think it's great to have multiple solutions as a controller on top, because that will greatly stabilize the API and make sure that there are no shortcuts that are taken upstream to quite complexity or do strange things. So that will really make sure that Voltha stands to its contract that was to truly abstract all the complexity of a PON network as an Ethernet switch. Because at that point, it will be required that all the controllers have the same access to everything.
Indeed, indeed, I totally agree with you, Theo, on this. Great, and whatever options that it gets picked, I believe that it's going to be a good success for the project. And it's
very possible that the community will not pick one de facto controller, because if you have 2 or 3 or 4 options which all work well and can control the stacks, and they may have different strengths. One might be more reliable, one might be faster, and so depending on where and why you're deploying, you might go with different solutions. I think this is actually
absolutely, and ONOS is still very much in the picture. if somebody wants a very stable, even though not like 100,000 scalable controller, that is still very much in the picture. So yeah, good is a menu. You can pick whatever dish you want. It's good news. It's really good news. So any questions or comments? Okay, then if not, I'll work with you, Raj, to get the code in the repos. Okay, good. The next topics of today's meeting are not that there's not that much else to discuss unless Amit has come up with a lower level proposal for the OLT disconnection. I think we can skip that point for today.
So Abhilash could present. He worked on some of the design items there, and I think he has some points to discuss.
Yeah, I can definitely give Abhilash sharing permission.
I'll try to share. Okay. I think so. I have already.
Okay, perfect.
My document is visible.
Yes.
Yes.
Okay. Now I'll just briefly go through how it is done currently in Volta. So here's the problem we could face are multiple, but I'll go one by one. So here, once the OLT is disconnected to the adapter, so what the adapter does is it will clear off regardless of the OLT rebooted or what happened to the OLT. The adapter will clear all the resources, and then once the OLT is connected back, there will be no reconcile or any sort. So what will happen is this state will leave the Volta and the OLT in different states. Like there could be ONTs which are already running with traffic, but still are running. But if you see in Volta, there are no flows for it. And there will be no device as well. So this, what will happen, any next further operations on the device, on the ONT will not be possible. And also it's a mismatch. So of course, if the ONT goes down and comes back up, it'll start working as usual. But still we would have missed a lot of indications, alarms, everything when the OLT is disconnected. And also the way how the adapter connects back to the OLT is based on a gRPC dial, which is blocked till the connection is received. So that also probably we will have to revisit. So anything on the current behavior, because this is what I think it is now. Correct me if I'm wrong here, Girish. Or
that looks good to me. It's a good summary.
Yeah. So now coming to the solution, how we can come over it. So now once the adapter loses connectivity to the OLT, right? So what we do is adapter doesn't do or Volta doesn't do anything. It just waits for the next connection back. There could be already ONTs running, traffic running, everything would be going fine or would not be, it depends. So what will happen after it loses connectivity and connects back after 10 minutes or 1 hour or a day or whatever. So what we can do is we can have multiple approaches. One is queue up all those events which happen during the time, okay, which of course will be an unknown size for the queue size. There will be a lot of questions on the queue size, how much it should be, because it can just be hanging over without the connection for a lot of days. Of course, it may not in production, but at least for a few hours, and a lot of things can happen. So we can queue all those events, and once the connection is back, we can replay all the events once the connection is back. So if an ONT goes down during the OLT has been disconnected, so that event will be queued, or if an alarm goes on, that event will be queued. So once the connection is up and re-established, all these will go through, and Volta will act according to the event which it has received. If a ONT is down, it will mark it as down and all the flows will be off. If an alarm is triggered, it will receive it and alarm will be triggered. So that's one approach of doing it. Of course, it will be the simple one, and of course we can improve it on it later by playing around with the queues and all. So
Sorry,
another
isn't this already done in Agent? I think Agent has only a capability to queue this kind of events, and when the connection comes up, it sends all of the queued events to the to Volta.
It is there, but I am not sure how big the queue is. Definitely, it's not big enough now. Girish, again, you'll have to correct me.
So there are two things in the adapters. As Abhilash mentioned, we clean up everything. So that will need to change. And as I'm not sure if it's a fixed queue size or a dynamic queue. That I'll have to check. If it's a dynamic queue, I think we already have the mechanism that Abhilash is mentioning as an improvement. If it's a fixed queue, probably that would need to change to dynamic queue, or probably a big queue with a big queue size.
Yeah.
Besides this, I'm sorry, I'm interrupting you too much. Besides this, do you also, here you propose also to not clean the resources during the reboot of the OLT?
I'll come to the reboot. No, I'll come to the reboot. First, I'll cover the disconnect because they are interrelated. Since if we change something during the disconnect, we'll have to change how it is handled during reboot as well.
Okay, so we have the capability to decide if this is a reboot or disconnection only.
Yes, I'll come.
We have this capability, so we know that when a disconnection happened and came again, we know that this is a reconnection, is not a reboot, because we have, I think we had some flags in the OpenOLT interface, which indicates if the OLT is in initial state or configured state, something like that. So we know that it's a disconnection, not the reboot. Okay.
Yes. Okay. I'll cover the reboot just after one more approach, after I explain the other approach. So the other approach would be to reconcile from the OLT. So what we can do is whatever happens at the OLT, all the events will be ignored by the agent because it doesn't have connection to the adapter. So it doesn't make sense to queue up as well sometimes. So everything will be ignored, and once the adapter connects back to the OLT, so the OLT agent can literally take a snapshot of all the ONTs and its states and use the same indication channel to send out the events. And also it can check on what alarms are triggered, and then create an event and send it across. So these are the two approaches. So considering on the complexity and easy to do, we would suggest approach one and probably enhance it further. So any questions here? Anything before I move on to the reboot? Of course, the reboot also will come in the same line. But I would like to clear if anything on the OLT disconnect, reconnect. Okay, cool then. So I'll move on to the reboot. So again, now the reboot works because once the Volta loses connection, Volta will clear everything off and OLT is rebooted. So once it's rebooted, both are cleared and everything works fine. So now if it's rebooted and we haven't cleared, if we take the case of OLT disconnect and reconnect, if we have that in place, so reboot, it would impact the reboot situation. So in reboot, what we can do is there is a heartbeat check which will happen in adapter to the OLT. So if that heartbeat is lost and we don't do anything as part of the OLT disconnect reconnect, and once it connects back, there is a value in heartbeat check. Every heartbeat check, the agent will return a value. The value is nothing but the start time of the OpenOLT agent. So when the OpenOLT agent started, it will take, I think so it's an epoch time value. It will take that value and send it on every heartbeat. So if it reboots, if the OLT reboots, or even if the agent reboots, that value will change. And adapter will come to know if it's rebooted. That's one way of doing it. The other way is simple, to have agents and a reboot indication. Okay, fine, I've rebooted. Either one of them will do. So in this case, once the adapter knows that the OLT has rebooted, then the adapter Volta, the whole stack, can clean up everything. The flows, the gems, what all the resources are located. And even in DT case, we'll have to clean up the ONT as well. It's the ONT device object as well. So once everything is cleaned, and then we can start off with the new discoveries and coming up with the new, whatever new discoveries come, we can start honoring them. So here, any questions so far? I'll move on. I'll start moving on to a few tricky situations.
Just one comment, Abhilash. The OLT adapter already knows whether the OLT was rebooted or disconnected. In the get device info call, there is a flag which is called previously connected, which is a Boolean that the agent can set in case of a reboot.
Okay, get device info will happen once the OLT is connected, right?
Yeah, the first time the OLT connects to the adapter asks for the device info, and as part of that call, the OLT will tell the adapter whether it was a reboot or just a disconnection.
But what about the subsequent restarts?
When it restarts, that flag gets reset to previously connected equal false, while if it was a cable failure or someone unplugged the cable, that flag will be true.
Okay. Now, in a situation where it rebooted once, so that flag will be set to 1.
No, it's a Boolean, so it's either true or false.
Okay, sorry. It will be set to true. So adapter will come to know. Okay.
Yeah,
okay,
so
we can
it
make
doesn't
use
know.
of that.
It doesn't know how many times it was rebooted or disconnected. But is that an important information to know?
Okay. Okay. So what you're saying is there are multiple ways of knowing if the OLT is rebooted. So one can be heartbeat check, one can be an indication, one can be this flag as well. Right there.
Yeah, I was just pointing out, as Mahir said, that this information is already available.
Okay.
Yes, and it's available, and I think it is already checked in the adapter. Adapter checks this flag to decide if this is a temporary disconnection or it's a reboot.
No, but it has already cleared the flows before that. That's the problem actually.
Yes, so we could avoid cleaning resources and just rely on this flag to clear or not clear the resources at the adapter.
Correct.
We back in the time, I don't know the time frame, but I think we discussed these issues and decided something on that. We discussed to differentiate short disconnections from the long disconnections. So in short disconnections, I think we trusted to the queues of the agent, and in long disconnections, we rebooted the agent. And for reboot cases, we also had some logics in the adapter to differentiate reboot from the disconnections. But we are, as far as I remember, we only had an open task here to stop processing the discovery indication during these cleanups in reboot case. Okay, so I think adapter currently checks this flag and decide if it is rebooted or not. So clear the resources accordingly.
Yes. This is what can be done.
I think it clears the resources. Sorry, my memory is a little hazy. But I think it clears the resources at the adapter as soon as it detects it's unreachable. There is no decision based on long disconnection or short disconnection, or based on whether the adapter rebooted or not rebooted in the get device info flag.
Correct. As of now, it's like that, but I see flags. I have seen flags wherein it's rebooted or no, but it's not making use of it as of now. Okay. Any further questions? Okay. Now coming to the tricky part. So now, since we have waited for the connection to come back up to the OLT, and we still have resources and we have connected the OLT back. So what can happen is, now since it's rebooted, the adapter or the Voltha will start removing the flows, deleting the ONTs and all. But at the same time, OLT can start sending the discoveries for the ONTs, because all the ONTs considering are all connected and up. So what can happen is there will be a race condition wherein sometimes the down adapter has sent a down for an ONU and flows are getting cleared up, and together we've got an up, ONT got activated from the adapter and the port went up in no-nos, so it'll go into a mess. So for that, what the suggestion or approach would be is wait for the flows to clear up before we start honoring the discovery for that particular ONT. Now, how do we do that? Now, every ONT will have a tech profile instance still there whenever there is at least a single flow. Even if one flow is there, that tech profile instance will still be there. It will not be clear. So what the adapter can do is, once it gets a discovery, it can check the tech profile instance is present or no for that ONT. If it's present, ignore the discovery, because we are assuming that the cleanup for the ONT is still happening. So we wait. Once it's cleared up, once we know, then we can then the adapter can start honoring the discovery for that particular ONT. So by this way, we ensure there will be no race condition and there will be no up down altogether happening at once. That clear on this part? Any questions on this part? Because I would like to have a discussion on this, because
yes. Sorry, I just was lost for a bit. If you process the events serially on per, I mean, I think every indication has a except discovery, of course. So if you process every event serially, wouldn't it solve the problem? Of course, serially would. Do you intend to process events parallelly, or how?
No, not parallelly. Why? Because Now ONOS, what it'll do is it'll ask to add the flow and return back. And once it gets a delete, it'll delete the flow and return back. But how the core adapter handles the flows and all will not know, because they are Go routines, right? And also the indications, down indication, and when the up indication came back. So in a scale, right, they can just be one after the other. Of course, 1, 2 ONUs, it'll work fine, but in a scale, it depends on how we are picking up the indications. The down can be here at one place, and the next one only can be an up. So in that case, everything will start happening parallel.
Yes, I agree that this is a problem currently in Voltha. As I said, we also have an open task for this, and yet not implemented.
Okay.
Yeah, this is the problem. And I passed the document link to the chat screen. So if you have time, please go and check this document later. It's about these issues we discussed before and had some implementations in place. Okay.
Okay. Yeah, sure. We can discuss. So you have still doubts, Girish? Or?
No. So my doubt was, if we start processing all the events queued in the OLT in a serial manner, why would there be a problem? Is what I couldn't understand. Maybe I missed some point that you mentioned.
And now we have picked up, okay, when this, but in northbound, okay, not all can be served at once. Okay, there will be a bit of delay. Some will be staying in the Kafka before some northbound picks it up and asks the ONOS to start deleting the flows or adding the flows. So what can happen is the indications can start piling up. So in that case, you've got a down, okay, and you've asked ONOS to delete the flows. ONOS deleted it, and you have picked up an up indication again. So again, you ask ONOS to add the flows. So now ONOS is still in process of deleting it. Okay, they are not completely deleted, and ONOS starts adding it again.
Okay.
Okay, so what will happen is, so add and delete will start going on in parallel.
So that will not happen, because we already serialize operations on a per ONU ID on that PON port serially. So I don't think there could be conflict of operations on a per subscriber basis.
No, it's not per subscriber, Girish. I mean, when you start to clean all the resources from OLT adapter, because the OLT is rebooted, then if you cannot clean all of the resources when you're doing cleaning this cleanup procedure, OLT comes again back, it starts to send the OLT discovery indications. And during this cleanup, if you start to say process this ONU discovery indication, you start to configure the OLT and ONUs, but on the other hand, the other threads try to still clean up the resources, the internal resource. So this is the conflict.
I see what you mean.
Okay. So, yeah.
Got it. Okay.
Okay. So,
yeah, got it. I understand the problem.
Sorry, Gish, go ahead.
Sorry, I was just saying I got the problem. Yeah.
Okay. A question here. I mean, how do you go to implement this? I mean, do you, enable the indications and just ignore the indications coming from the OLT, or you will not start the indications and do not create the indication channel between the OLT and the OLT adapter? So these two implementations, I think, has different say behaviors, because if you don't create the indication channel, then the indications will remain in the queue of the agent, I guess.
Yes, good point there, Mike. So what we can do is we'll enable the indications because we still don't want to miss out on any of the alarms, right? So any discovery comes, as I mentioned, we'll check the tech profile instance. So if tech profile instance is there, we will ignore it, the discoveries. Of course, we on the ONT front, once the OLT is rebooted, we can expect only discoveries because adapter is the guy who enables it. So if he's not enabling the ONTs, we'll not be expecting any more events from the ONTs, right? Only the discoveries will be coming. So we'll ignore it till we clear off the flows, the tech profile instance. And in DT case, we'll have to wait for the ONT to get deleted as well. So that can be worked out how we can do it, but the basic idea is to clear up the resources. The only thing is we'll have to get the OLT and the Voltha both in one state before we start doing further processing. Of course, we'll not wait till all of them are complete. We'll wait at least one ONT for one ONT. One by one, ONT one after the other. So in that case, it will still happen parallel, not on a particular ONT.
Okay, but seems a bit complicated to me. Still have the chances or risks to have the same problems again.
I'll go to the risk. As you mentioned, the risk. I'll go to the risk. I have it here.
Okay, then why don't we think to say stop the indications totally and say recreate the indication channel after all the cleanups finalized? I mean, what's the problem there, or why do you want to do it in parallel? I mean, stay with the indications alive and cleanup going on.
Yes. Why is now we'll have to wait for all the ONTs to get deleted.
So
okay,
what's the, I mean, the reboot cases or reboot of the OLT already takes long time, you know. Is it thinking that we currently have 4,000 maximum subscribers in an OLT? Is it too long to clean all of this 4,000 subscribers information?
Yes, but why? Because we are starting the cleanup once we got the reconnection back to the OLT. So OLT reboot 2 minutes, 3 minutes, whatever it has taken. Yeah, but again, we'll have to wait for all the ONTs to get deleted. So that will take quite a bit of time, depending on how many flows you have and how many ONTs we have. And also what will happen is we'll stop the parallel processing between the ONTs. Right. So if ONT 1 resources are cleared and ONT is gone from Voltha, Voltha is free to take that discovery. So let's take that discovery. So we'll take, and also if we stop that indication channel, what will happen is we could miss out on a few alarms. Of course it's highly unlikely, but still we cannot say. So it's better to have the indication thread enabled.
My 2 cents here. I mean, it's we'll still have to discuss much of the low-level details that you're mentioning here, but in general, it's okay to be slow than to make some mistakes being fast. So I think that we should consider in the future as well. Yes. If you're slow, and you're stable and you're predictable, it's okay to be slow. But if you're confident that everything works fine being fast, yeah, just choose that option. I think you know that, but I just wanted to reiterate that.
Yeah. Agreed on that. Girish. Yeah, we can. What I'll do is once we have a good understanding of this, I'll come up with a detailed document on how I'm planning to do it, how we are planning to do it. So then we can discuss in detail.
Just one comment on being slow. I generally agree with the point that it's better to be slow and safe. But we have observed with Voltha that if we are too slow, then we end up in a situation in which the flow installation or removal starts timing out, and then the controller start asking for that again, and we end up in this loop in which we pile up a request, and it's hard to recover from that.
Yeah, good point too. I mean, it's a fine balance.
So I agree with the general point. It doesn't always work.
Yeah. Well, what I was trying is to get the best out of what we have. So we'll see if we see any issues wherein we can get into issues wherein we will not be able to recover. Yes, agree. Then we can switch back to and wait till everything is cleared off and only then start the application thread.
By the way, Abhilash, this is a good proposal. I think you're suggesting to, process the discovery for an ONU serial number that has already been cleaned up. I mean, seems logical to me. I don't see any particular issue here.
Yeah.
But yeah, I mean, I just said a general thing that sometimes it may be okay to be slow. But this seems okay to me at first look.
Okay. We'll discuss further, Girish, once I come up with a detailed document.
Yeah, I mean, probably because I and Mahir, probably some others know the low-level details, so it makes sense. When you have some other document, if you can put some sequence diagrams, probably for a few others, it might make sense too.
Yes. In my next one, definitely I'll put.
Thanks a lot, Abhishek.
So coming on to the problems with these approaches is what if the flow doesn't get cleared at all? One flow is hanging out for that ONT and it doesn't get cleared. So in that case, the discovery will never be honored by the adapter. Here we can enhance further and have a timer or number of discoveries we can ignore, and then after that we can do a force delete of that ONT. Of course, if there is a flow still hanging around, even if we honor the ONT, still there will be problems because there are flows still hanging around and we are trying to install a few more flows. So again, it will be a mess. When a mess is already massive, we are putting some more trouble to that Voltha. So I think so what we can do is wait for a few, ignore a few discoveries, 10, 20, don't know, depending on how we find the data, how we get the data. Depending on that, what we do is we force clear and everywhere so that everything is cleared. And of course, once if the ONT is down and sending discoveries, of course the ONU will not be having any flows, so we can clear the rest and start honoring the discoveries. So this is one suggestion which we can enhance later depending on how we go ahead with the plan. Okay, moving on. So here the DT workflows, what happens is once an ONE goes down, we delete it. So for DT, just looking into the tech profile instance will not suffice. So we'll have to look for the ONT object in the adapter as well. And probably for other use cases, for other workflows, it may not be the case. So we can have a flag in the deployment file and do the checks accordingly. So that should be pretty straightforward. Any Any questions here? Okay, so I'll just briefly explain how this will solve numerous problems. Okay, so here the first one will solve the OLT disconnect reconnect, and OLT reboot we have discussed, and the tech profile instance and honoring the discoveries, ignoring the discoveries will solve the case wherein we do a reboot, in a case wherein a pawn loss happened and it recovered within a second, because a pawn loss will trigger if we don't get a signal within 100 milliseconds, right? So there can be many situations wherein it will flap just like that. So if it flaps again, the same situation comes, all the vintage will go down, and again within a second all start sending discoveries. Again we'll end up in the same situation, all happening at parallel. So this ignoring of the ONU discoveries and waiting till the flows and vintages are cleared will solve this problem as well, and also will solve wherein we disable and enable the pawn. So if northbound, anyone disable and enable the pawn just without waiting for anything. So even then we'll go into the same problem, because everything will start happening parallel. And also some ONTs which are flapping, like they'll come up due to some attenuation problem or anything, they'll come up, after some time they'll go down. There can be many, or the connection may be bad on the cabling, may be bad, so ONTs can come up, go down. These are like real world situations wherein we see a lot of these things. So these all will be handled with a solution which I've proposed. Hope I'm audible. It's very silent.
It's a pretty good start, Abhilash. Looks good to me.
Okay, thanks, Girish.
Yeah, I think this looks good. Let's flush out some of the items that were discussed today and some of the things that we brought up. I also shared another document that we used a while back to consider failure scenarios of boot and things like that. So that is maybe worth having a look at. I know Amit knows about it.
Okay. If anyone wants this document, I can share. Probably the raw data here is what we spoke, but it's in raw data. But I can come up with a different document next time around with a few, because it's hard to understand the flow considering the down, up, and all. So I can come up with a document which clearly explains how it behaves, and also a few more write up on that. And anyone who wants to discuss further probably can ping me on Slack. I'm free to discuss. Good. Okay.
Yeah, I think it's so good. If you can share this document, I will upload it to the TST doc and for everybody to take a look at. So yeah, let me know the next steps once you flush out some of these elements.
Sure, I'll share it.
Thanks.
Okay, took quite a bit of time. Thanks everyone. Done from my side. Thanks, Andre.
Okay. Yeah, that's great. Thanks. Thanks a lot. So I think the next step is to get this document up, a few improvements there that we discussed, and we can take it on next time again. We have 2 minutes, so let me open up the floor and see if anybody has anything that they want to bring up or discuss. Okay, then if not, thanks everybody for joining. Theo, can I ask you to upload the recording of it to YouTube?
Absolutely.
Thanks a lot. And let's talk again next week. And I hope to see some of you in person in next week as well. Cheers. Bye-bye.
Goodbye, everyone. And thanks, Abhilash, for the presentation. It was very interesting.
Thank you. Thank you.
Bye.
Bye-bye.
Thank you, Abhilash, and
Bye.
bye-bye.
Cheers.